Welcome back to the channel. If you tune in our recent podcast episode, How to Verify What Save Lives, you already know how vital safety critical elements or SCE are to keeping operations safe and under control. This video is a continuation of that conversation. We are now zooming in the verification life cycle of SCE, providing detailed insight into how these elements are verified, tested, and maintained from design all the way to the decommissioning. Whether you are a seasoned engineer or just stepping into process safety, this walkthrough will connect the dots between the strategy and the field execution. So let's begin the following a single safety instrumented function across the entire life cycle. Let's start at the beginning, performance standards. These documents define the who, what, and how of your SCE. They clearly state what the equipment must do, under what condition, and how you will verify it. The performance standard must define the function of the SCE, the environment it will operate in, how often it will be tested, who will test it, and what the pass-fail criteria are. Let's say we are designing a sieve to prevent the overpressure in a reactor vessel. The performance standard might specify the pressure transmitter must detect the high pressure within 1% of accuracy, and the shutdown valve must fully close within 2 seconds of activation. That's precise, testable, and life saving. If you skip clarity here, you will pay it in our confusion later. A weak standard today can become a dangerous assumption tomorrow. So once your performance standards are in place, it's time to design the system. But before anything is built, we need a design review. Think of this as a technical interrogation. Does this design meet the performance standard or just look good on a paper? The design must be verified to ensure it will meet the required function and foreseeable operating condition. This should be a documented review involving all relevant disciplines. In our SIF example, we would review sensor placement, response time of control logic, and actuator speed, also redundancy. Even software logic get scrutinized. Every flaw caught in a design review, in a crisis you just prevented. Don't rush this stage. It is your first real safety gate. FAT involved testing the control system logic, panels, instrumentation loop, and interlocks before shipment. It confirms the equipment works as intended per design. We simulate input signals, like triggering high pressure, and confirm the PLC logic closes the valve within 2 seconds. We validate alarms, diagnostic, and fail-safes. You wouldn't fly in a plane that wasn't tested on the ground first. So why trust a safety system that hasn't had a dry run? All right, the gear is on site, but this isn't plug and play. Now we validate installation and integration. SAT checks the complete loop after installation: wiring, I/O signals, logic sequences, and control responses. It confirms all connections are correct and working. We energize the transmitter, simulate high pressure, and check the valve shuts in exactly 2 seconds, not 2.5, not around 2. The system must respond exactly as designed and documented. If a FAT proves component work, SAT proves they work together in a real world. Don't skip, don't assume. Now we are turning the key, putting the system into service. But before we do, we verify everything works under the live conditions. Commissioning verifies correct installation, power up behavior, signal ranges, fail-safe states, and initial proof test. All documentation is finalized. We run a live function test, simulate high pressure on the transmitter, observe the PLC response, and confirm the valve shuts. Alarm activates and logs are generated, all while the system is energized. If you launch a system without function test, you are flying blind. You don't hope a seat belt works, you test it before driving. Okay, so your SCE is installed, commissioned, and ready to roll. But here is the big question: is it ready to protect lives? That's where the independent competent person or ICP step in. Think of them as the final gatekeeper before an SCE become operational. You will coordinate the ICP visits. That includes giving them full access to documentation, test reports, and the facility itself. But don't just hand them a file and hope for the best. Engage with them, answer questions, be transparent. Their job is to verify the SCE not just on paper, but in reality. In our SIF case, the ICP might request to witness the shutdown valve in action, checking if it indeed closes the specified 2-second window when triggered by the pressure sensor. This is your chance to check errors before they become disasters, so don't fear out it. Embrace it. So you passed your initial ICP review. Great. But here is the reality. Compliance isn't just one time thing. SCE degrade, conditions change, people forget. That's why ongoing ICP verification are critical. These are not just paperwork review. They are full compliance audits. And you will make sure all inspection records, maintenance logs, and proof test results are easily accessible. You will also coordinate the access of the ICP to validate SCE conditions. For our SIF, that means periodically testing the shutdown valve to ensure it still closes within 2 seconds, not just when it was new, but after a month or year of service. Ask yourself, would this safety function still work if something went wrong right now? If you are not 100% sure, neither is the ICP. Let's talk real life. You have got hundreds of instruments, valves, and control systems, all buzzing away in a daily operations. But for SCEs, you have got no margin for errors. Maintenance here isn't just about preventing breakdowns, it's about preventing safety integrity. Your role, make sure maintenance team have clear strategy, align with performance standards that includes inspection intervals, proof test frequencies, and calibration plans. In our safe loop, we routinely calibrate the pressure transmitter, confirms its accuracy within 1%, and inspect the shutdown valve for wear or drift. If there is any deviation, even a tiny one, it get logged, corrected, and followed up. Every click of a spanner and every test result you logged, it is not just maintenance, it's life protected in advance. Okay, so we are keeping up with the maintenance, but how do we know everything is still working as designed? You guessed it. Schedule inspection and testing. Now, here is the trick. It is not just about checking boxes, it's about interpreting the data. Look for pattern, inconsistencies, degradation. You will document everything: the who, what, when, and what next. Suppose the shutdown valve doesn't fully close during the quarterly test. That's a red flag. You investigate, discover actuator wear, and replace the component. Ideally, before it ever needed in a real emergency. Your test results are trying to tell you a story. Are you listening? Here is where we zoom out. You have got the test result, maintenance logs, ICP reports. It's time to connect the dots. Performance reviews are not just check ins, they are strategic. You will look at trend, compare against KPIs, and ask critical questions. Are failure rate increasing? Are inspection being missed? Is performance slipped under the radar? Let's say the pressure transmitter in our SIF has a required frequent recalibration over the past year. That might indicate age related drift, suggesting a replacement program is due. Here is the golden rule: if you are only reacting, you are already behind. use data to stay ahead. We get it, plants evolve, upgrade happens, but when it comes to SCE, you can't afford surprises. Every modification must go through a formal management of change process, from a simple software patch to replacing a sensor. Risk assessments, updated performance standards, and design review must be completed before any change is implemented. Imagine replacing our SIF pressure transmitter. The new one must still meet SIL 2. Its response time, diagnostic coverage, and even its failure mode needs reassessment. Then we update documentation and retest the system. Change is good, but only when you are in a control of it. Even the most reliable SCEs reach to the end of their life. But here's the rule. Never decommission an SCE unless you are absolutely certain it's no longer needed. You will conduct risk assessment, validate alternative safeguards, and update the safety case accordingly. Let's say the redesign eliminates the need of our pressure-based SIF. Before decommissioning, we must verify a new overpressure protection system is fully functional and independently verified. Every SCE decommissioned without replacement is a hole in your safety net. Don't pull the plug unless the system is watertight. And there it is, the full life cycle of the safety critical element verification, from the drawing board all the way to the respectful retirement. Our simple SIL 2 pressure sieve walk through every stage: design, commissioning, testing, and eventually replacement, always under strict verification. Because at the end of the day, SCE are not just a checklist, they are a silent guardians waiting patiently for the day they are needed. SCEs are not just components, they are commitments. Commitment to protect people, the plant, and the planet. And as engineers, you are the steward of that trust.